All right, let's get going here. All right, so in order to do this panelization, I'm going to start again here. I'm going to copy this Boolean intersection. There we go, of this surface. So as we talked about in class, I can use this command curve from object dupe edge, and I can duplicate the edge like that. And I can put that on a layer here and join it. And then I can go curve from object, duplicate edge, and I can duplicate the other edge. Join it like so. And the reason, again, that this is going to be problematic is that I've got two different edges that are both connected by a surface, and so it's going to be difficult to find a panelization strategy or a network of isocurves that's going to account for both of the edges. So in order to see that, let's explode this and let's put this surface here. So you can see there's two surfaces here that were left over from the original two surfaces here, and they meet along two edges. So to get started, let's have a layer here from our isocurves. Let's divide this curve. You need something to control the spacing of the isocurves. So let's go divide. That's the command, and I'm going to type a number, which is going to be, well, actually, first it's asking me to drag the seam, so I'm going to ignore that. Just hit space, then type a number, which is going to be 18 for me, and then I'll do cell last, and I'll put those on this divisions layer, okay? And then over here, I could do the same thing, but I'm just going to start with this one. So I'm going to go extract isocurve from this surface. I'm going to be using this first layer, and I'm going to go around. It could be either U or V. I'm going to go around and extract isocurves at each one of the points. So you can see, because the surface was split, when I created it, there's a problem, which is that it won't cross the broken seam. So I have to actually manually start again, making isocurves to finish the isocurve around the broken seam. Like that. Okay. So now I'm gonna hide all these other things here that we don't need for this file. Hide this. Okay. And now I'm going to go select all of those from their layer, join them. That's joining the broken ones across the seam. I'm going to switch my layer, and I'm going to go get the opposite direction. Here's another seam. Careful not to miss. Look, I missed. Very important not to miss. So let me fix that one. Let's see this int snap or the point snap. Should just have those on. Int, end, and point are the only really good ones. Oh, the other thing I forgot to mention is when you're doing this, you really need to have your modeling aids, your use apparent intersections off and your snap to occluded objects on. That's because you don't want to be selecting something that you think is an intersection, but it isn't actually, is actually just two overlapping lines in the view. Okay, so I got the isocurves from one surface. Let's go and get them from on the other surface. Switch our layer again. First, let's join these. Okay, let's extract the other ones. Then I'm crossing the surface corners. Like that. Okay. Now I'm going to extract the other ones in the other direction. Change my, well, first let me join these. Then let's extract isocurve. U, switch my layer again. Sorry, it's V. And let's go along. Get the network. Meeting at the corners. Okay, so let's join those. So now we've got a network of isocurves and another network of isocurves. So why is it important that they meet on the corner like this? Well, it's, if I start to try to panelize this, I can put in some panels and it'll construct the edge, which is pretty helpful. Because you actually, even though the surface is becoming sort of discretized and chunky, you can still see the edge sort of precisely made. Whereas if I look at the other side, all these sort of ragged isocurves that aren't meeting at any particular point, and actually, if I wanted to make a surface here, I would, and I drew a surface there, this surface would actually not be planar. And you could find that out if you sort of draw the intersecting curves and try to intersect them, they won't intersect. Or if you draw a polyline and you try to go planar surface, they'll say no faces were made. That's because this is not at an intersected point. Reason these points produce planar surfaces is because we're using special types of surfaces right now that behave this way. So if I want to complete this, if I want to find a panel here, what I would need to do is fillet or extend these edges till they meet to find the missing corner. And I can do that either by extending it. I could go curve, extend curve by arc. Or I could fillet, extend curves by arc. And I can find the more of the surface really that was sort of trimmed off. And then if I want to put a panel here, I can start to fill this in. But you'll notice that these panels are not meeting the line of the edge. They're sort of passing in a bizarre bizarre moments. And so if I were to do this also with the other ones, I would end up getting these panels that trimmed each other in somewhere that wasn't really near the edge. So in order to do so, I would end up losing this moment of continuity, the beautiful sort of curvilinear intersection. You might be okay with that, but for our purposes, the geometric precision of trying to find a network of curves that can cross is something that we're going to be pursuing as a stand-in for the other types of precision that you might need to search for. Okay, so I'm going to keep going with this. And basically, what I can do now is I can select cell layer, and I can copy one of the surfaces out with its isocurves, and I can cell layer, and I can copy the other surface out with this isocurves, and now I have two surfaces that I can go in and panelize. So we talked about several ways of doing that in class. The first one is going in and clicking on these points and creating the panels one by one by one by one. And then at the edge that's clean, you end up with one series of triangles next to a series of quads. We also talked about another method, which is taking a piece of these isocurves, completing the surface so that they you have a sort of a group that is bounded with the same number of parts, so it doesn't have any hangers off. And then you can pick a set of them, split those with all the other ones. Then what you end up with is a series of arcs that are split at all the intersections. You gotta deselect the extra hangers off, so they are sort of a contained group. Then you can rebuild. So right now they're degree 2 with 3 points. That means they've got a little curvature. You can change them to degree 1, so they'll be straight with 2 points, so there'll be lines. Join, hit OK, then join them. Make sure you don't have any hangers off, and then you can loft them together. You got to use this straight sections command and hit OK. Then you can copy this, cut it, Control X, and then undo all the way back before you did that, damage to your underlying model, and then you can paste it. So that's a faster way. And then the last way that we talked about was to go to Tools, RhinoScript, Load, and go add the reorder geometry script that I gave you, and then click on it and click Load. And then it'll ask you to pick objects in the correct order. So you could hit escape there. Now that it's loaded, you can go RhinoScript run. Sorry, Tools, RhinoScript run. You can click here and hit OK. And then you have to just go around and select these in ascending or descending order. Because this is a torus, the order is the starting point is unimportant because it goes all the way around. And when you hit finish that, you hit enter, and then you have to wait for it to finish. Those are now grouped and ordered. And then you got to do the other one, other direction. The reason this is important is because Rhino, in its memory, groups curves or anything in the order that it was created. So because you're going around and creating them in all sorts of a willy-nilly order. When you actually go to use the script, it'll be very, it won't know which order to position them in its memory in order to try to create a grid of points. So the easiest way to solve that problem is to just reorder the points themselves, the curves themselves, before you convert them to points. Okay, so now I can go to Grasshopper here. I can open up my discretization panel from UV curves. And Grasshopper just takes some data from Rhino that you input. When I give you inputs, they'll be in these red squares. It processes them for a while, does some operations, and then you have to right click and bake them back into Rhino. So whenever I give you something to bake, it'll be blue. So when I give you a script, you won't have to do anything to the middle. You'll just have to go over here. So you'll just go over here and set these curves. Go right click and go set multiple curves, like so. And then you can select the other group of curves, right click over here, set multiple curves. And you can see the panelization is appearing. You can go over here and go right click on this and go bake. You can group the output, and then it'll appear. And then you can close this, go over here, and it did not complete the rows, the start and the end, because I didn't write the script to do closed shapes. So the first and the last row are not being closed. So this last part you can do manually. You can go point, 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 point. You have to be careful not to miss a point, as you know, because otherwise it ends up not planar. Here we go. Here we go. Here we go. And then it looks like the perfect edge also was not filled in. If I go over here and I copy the edge curve over to here, you can see that's where the row of triangles happens. So you can create that in this way. Okay, so let's do the other one. Once again, I'm going to copy that edge curve over, and there are a couple different ways of doing this. I could fill in individual panel by panel, and that is actually important to know how to do, because sometimes the other methods don't work. And also when you are designing these things, often you want control over the specific shape of the panels. You often want to adjust them locally. The other method, as I went through before, is to select a group, split them with the other curves, rebuild them with degree 1 and 2 points, and then get rid of any sort of extra bits so they all have the same number of segments, join them, loft them with straight sections, cut this, undo till before you split, and paste and explode. And the other method is to go Tools, RhinoScript Run, or to load it sometimes, RhinoScript Load, Load, Tools, RhinoScript Run, reorder, and then I can pick my curves like so. Pick the other order. Then go to Grasshopper, set multiple curves, select the other group, set multiple curves. By the way, if I use this version, set multiple curves, it'll make the triangles. I can go over here and go big. I still have to make the missing panels. This one made extra triangles though, that I have to delete. Oh, look at that, I missed. So if I find that I made a mistake like this, I need to delete these panels in this section. And do this, go back to the surface, find where the mistake is, get the isocurve, put it on the right layer, delete the other, bring that over, and then I can remake these panels using one of my methods. Oh, see, I lofted with an extra bit, so see what happened? These became all twisty. I did it again. There's the extra bit. There we go. Explode, cut, undo. Okay, so that's both surfaces panelized from one edge. And remember, the other edge is still messy. So what I did here is actually lock, swap, cell curve, cell point. I actually did it twice. Once from the preferencing the other curve, and once preferencing the first curve. So I'm going to show you how that works and why I do that. So here, let's extract another network of isocurves. Let me try doing both at once. Now I'm just going to switch over to one. The reason I haven't been doing this is because now I have to go around and put them on layers. So it didn't really save me any time. Okay, there we go. Let's put them on layers. It's lock, swap, cell curve. just first put these on a U layer, and then we'll deselect. I think that's faster. I'm going to join these, and I see I made a mistake here. We're deselected. All right, there we go. So I can put those on the other layer. I can cell last, join those. Let's make sure these are all on the first layer. Excellent. Okay, now I can go here and I can extract a set of isocurves this way. So let's select these, join those, and these, join those. And there we have it. Okay. Now, what I wanted to do this for is I thought it would be interesting for you guys to see when I overlap these, an extra surface in here. When I put them on top of each other, there are two networks of isocurves that are not really correspondent. So the question is sort of how to bring those together. And there are a couple of different methods. In class, I went over two of them. So here, I'm going to basically hide all these, panelize the other set of surfaces. Okay, so here I can delete this. And I can panelize these, which if you look are going to be, I align them backwards here. Let's align them correctly. That one would go there. This one would go here. So this is the same surface again, but it has a different set of isocurves. So let's just panelize that. if I don't reorder them, the panelization script won't work. Right? Set multiple curves. There it is. Bake, group, okay. And then this I can put on this other panelization layer. And then I can go in and fill in the missing ones. All right, there we go. And then I can do this one. I want to show you another technique for telling if something is planar. And in order to do that, if I just do this, draw a polyline and do planar surface. If it doesn't fill itself in, it's not planar. All right, let's panelize this. Okay, so what I'm going to do now is I'm going to select that layer, and join those, like this layer, join those, and then we got to get these to come together. So in order to get them to come together, what I'm going to do is I'm going to take the blue, this surface that preferences that edge. Oh, let me get the edge curve. These surfaces, these panelizations preference that edge, these preference that edge. So what I'm gonna do is I'm gonna take this one that preferences this edge. And I'm gonna take this one that preferences that edge and put them together. And so now I've got the blue one is the first surface, and that's sort of holding the beautiful line there, and the blue surface holding this beautiful line, the tan surface holding that beautiful line. And so then I am going to fill in the rest actually just with triangles. So we often try to avoid having triangles, and that's what we're going to try to do mostly in this class. And there's a couple of reasons for that. One is when you're building things, you're mostly building things out of planar sheets of rectangular material, and so you waste a lot of material if you're cutting things into triangles. Also, triangles sort of visually busy, very distracting. Also, there's a lot more joints, a lot more structural nodes, a lot more possibility for leakage every time you have to have a joint. So in real life, there are a lot of reasons to avoid triangles that are both aesthetic and also environmental and also practical. However, you can't completely avoid them. So we just try to minimize them and place them in places that are, designed to look not be as distracting as they would be otherwise. So I when I'm doing this, I often worry a lot about the direction I'm placing my triangles and things like that. But I will show you something. We're missing the surface here. Let's see what happened in the original. Something happened here. I just missing something. Let's see if that was all I'm missing. So last. Oh, I went to the wrong one. It's this one. And I am something looks very messed up here. Okay, so I clearly messed up. So I'm gonna delete these two rows. And let's go find where that was. The surface, there it is. That's good. There we go. Oh, look at that, much better. So there, those two isocurves go here, and then I need to recreate that. So let's use this method. There we go. Okay, so let's lock this, lock swap, cell surf, cell polysurf, join, unlock, delete that, copy this over there, and see if we can, yeah, now we're good. So I can keep going back, filling in this with triangles. And when you do your project, you can use triangles to resolve the seams. That's legitimate. And you can also make attempts with some of the other techniques that I show you in some of the other videos that we'll discuss in class to limit the triangle. So when this gets too close to have a nice triangle, sometimes I might just remove this extra surface so that I can have a legitimate surface there and keep the topology looking normal. As I discussed in class, it is possible to resolve the edge without triangles sometimes, or with only one row of triangles. And I did go over in another video that I have uploaded a method of doing that. So if you're interested in that, how that works, you can see that particular video. I'm deleting some extra panels to try to keep the topology okay, and to try to keep the surfaces from being too tiny. That's a ridiculous surface. So actually what I'm going to do is give this panel its own shape. And so you can resolve the edge like that. And if you do that version, you end up with the one over here called version 1 that has the panels around the seam like that. But another way to do this would be to try to not locate the triangles along the seam. And in order to do that, what you could do is instead take the two different panelizations of the same surface. So if I put these on top of each other, these are two panelizations of the same surface. However, one of them preferences one edge, the other preferences the other edge. And so what I can do is actually start to take them apart and try to find a seam in the middle of the surface where they can meet. So in order to do that, I would start removing a string panels. Before I do that, let me show you that I would end up doing it with both surfaces. So this is the other surface. With two versions of the same surface. Okay. So then what I can do is look for moments in one of these surfaces to start where there's a nice kind of narrow gap between the panels. And then it's like blue is that way. So I did this backwards. Blue is there, tan is here. So tan and blue can try to have a skinny seam between them. All the while my goal is to keep I lost my idea, I'm sorry. All the while my goal is to keep the surfaces from touching the edge. So I want to keep the seam in the middle. So let's go along this way. That's why I'm getting this. I'm using a command called extract surface and then deleting. Extract curved surface and then deleting. And I'm trying to get this seam between the surfaces. extract surface, deleting. Triangle. Okay, and then I like these sort of moments like this also. This is possible, by the way, where two panels intersect. So what I would do, before I do that, let me show you what I would be doing. So I would go through here and I should be able to construct a row of triangles that is filling in the seam. And what I have is one edge dominated by one type of panelization and the other edge dominated by the other panelization, and the seam is in the middle. I should be able to get a single row of triangles that I'm not a huge fan of this because this got so close to the edge. Maybe I would want to do it differently. Okay, so this is what I wanted to show you guys. I think it's a really interesting little condition here. If I intersect these two planes are intersected. If I intersect them, they intersect on a line. That's because any two planes that are not parallel in space intersect along a line. So what I can actually do is I can trim those planes a little bit, adjust their shape so they meet on a point, and then fill this in with two triangles, and I've actually reduced the number of triangles. And if I wanted to do it again, all I would have to do is, extend this surface and extend this surface till they intersected. They might not intersect in a good, useful place, So it might not always work. They might intersect super far away from this spot, and I couldn't do this. But if they do intersect, I can do that, and then I can get rid of another set of triangles. And I end up with this sort of much more checkerboard condition. So I wonder if I could do that again here. Let's see if it'll happen. I think I might have to do something like this: extrude curve, a long curve, make like an extra panel, intersect those. I'm not so happy with that. That's a very funny shape, but I'll show you what happens. I got two very weird quads and two triangles like that. So I don't know if that's better. Another way of doing it might have been just to extend this one, extend that one till they intersect. And then I could have gone from there to there. And I could have split that like that with this one like that. Or let's try it in a different spot that's more normal for the other one. Let's try compromising. So I can actually reduce triangles that way. Here it is again. So well, actually those, it should have been this one, I think. There we go. So I can draw a curve and trim it myself, draw a curve, trim it myself. And then I can fill in the triangles this way. And then that ends up being this sort of migratory seam condition that you see here. So let's get rid of this one just for goodness sake. I'm going to do surface extrude curve along curve. That's a quad. And then that's, these triangles can go to there. So you see, if I can find a quad that accomplishes the task, I don't need the triangles. Okay. What about here? Let's do it here too. Surface extrude curve along curve. All right. Let's just there we go. Okay. Right there too. Any point along that line will be in both planes. And triangles can kind of do anything. There we go. Okay, so you get that zipper going along. I'll do it here. Not really doing it for me. Let me get a funny one. Let's see the funny one. Maybe it should be those two that would intersect. Let's try that. Okay. So that's sort of pretty cool. And then if I were to do that for both surfaces, I would get this final version here. So I'm gonna take the other half, what I did here. You can just see here I have the completed version on both sides. Let's look at that. That this one doesn't have the special. This one has the zipper all the way down. Doesn't have the special removed intersected planes that I was doing on this one. Okay. So that's how that works. And yeah.